The third set of identities that we're going to start with now are called the symmetry identities, and it is the same type of symmetry as we talked earlier about even and odd functions. So we've got our sine, cos, and tan function. If you remember the symmetry from before, sine x is a perfect 180 rotation of itself around the origin. So sine x is odd, which means that f of negative x is the same thing as negative f of x. So we can sort of just pull the negative inside and outside of the function. Cos x is that reflection across the y-axis, so that's even. And that means that f of negative x equals f of x. The minus just kind of cancels. And tan x, you can get this from doing sine over cos or sine of negative x over cos negative x. We can also see that it is a rotation of itself, so that's also going to be odd, which satisfies f of negative x is negative f of x. And so that's going to give us our symmetry identities. Sine of negative x is the same thing as negative sine of x. Cos of negative x is the same thing as just cos of x. That minus just kind of disappears. And tan of negative x is the same thing as negative tan x. All right, so we're just going to prove this one identity here. This doesn't really give us too much more in the world of equation solving. So we'll just do this identity. I've got cotan of negative x times sine x equals negative cos of negative x. So as always, I'm going to split this in the left side, right side. Left side is cotan negative x sine x, and the right side is negative cos of negative x. Now we can't get away with just knowing the two sine and cos relationships without needing to know the tan one, because the tan will just come from pulling apart the cos one. So instead of generating a whole new relationship for this cotan negative x, I'm just going to rewrite it as cos over sine. We do know that identity. So that is going to become cos of the same inside negative x over sine of negative x times sine x. And the next thing I'm going to do is use symmetry to clean all of these up. So I'm going to use symmetry on cos negative x, sine negative x, and cos negative x. So we can clean all of those up. We should get on the left side, that's just going to be cos x on the top. And the bottom is going to be the negative sine x. It's going to pull out of the sine function. And then times sine x. And the right side, that negative is just going to cancel. And I'm left with just cos x, so negative cos x. And then we can see some cancellation along the bottom on the left side. And what we're left with is negative cos x, which is the right side. So we're done. So yeah, we can just use it in sort of simple ways right now, but it'll show up in some of the explanations that we do for bigger identities in the last chapter.